So there's our volcanic eruption going on in Aso in Japan. That's what you're seeing currently. Back to our, down to the Earth's core.
Power that can melt solid rock, heating it to over 1,000 degrees Celsius. Blast bombs of lava as big as buses thousands of feet into the sky.
So now the problem with trying to harvest this as far as geothermal energy is concerned, we've tried high heat ceramics, we've tried different types of water cooled systems, and the lava pretty much just eats everything up. So I mean, we haven't been able, it's just too much. So but in the surrounding areas, in the peripheral areas, like over on Oahu and on the big island of Hawaii, they laid out some manifolds, ceramic manifolds on some of the encroaching lava fields, and then they'd set up turbines, steam-driven turbines on trailers, and then as the lava flow encroached over the circulating fluid in the pipe structures, they'd run it through the turbines, and then as the lava got too close, they'd just pack it up and move the turbine further on down the road. And that got to be kind of too expensive, wasn't it?
And send a wall of 800-degree ash and rock down the volcano at 240 kilometers an hour. Get in its way, and the ash would fill our lungs, burn, and suffocate us. Grit and hot toxic gases would sandblast our skin. The world beneath the surface has the power to blast millions of tons of gas and pulverized rock high into the atmosphere, creating acid rain, blocking out the sun for months, even years on end. And this is just one volcano. There are 600 or more round the Earth that are still active. 3/4 of them sit in a ring of fire around the Pacific Ocean. These volcanoes trace the line right where the Pacific Ocean plate sinks below the continental plate.
Classic subduction, so that suboceanic plate now, as it dives under the continental plate, is subducting or diving underneath, and that's that replenishment that we just looked at in the Marianas Trench there. But it's happening, all the way around the Ring of Fire, and also it's reflected in the continental, the landforms. So it's happening in the Atlantic also, and around the poles.
From here, we can see how it's all connected. The plates, the San Andreas Fault, the mid-ocean ridge, earthquakes, volcanoes. They're all part of the cycle of destruction and renewal that makes our planet dynamic. But there's one cluster of volcanoes that doesn't fit in. Thousands of kilometers from the Ring of Fire, in the middle of the Pacific Ocean, is the volcanic island chain of Hawaii. Hawaii sits in the center of the oceanic plate, far from any crack in the Earth's crust. These islands shouldn't exist. This is the Big Island, home to Hawaii's most active volcano, Kilauea. The volcano erupts along a series of rifts, spewing out up to 500,000 cubic meters of lava every day, enough to resurface a 30-kilometer highway. As it cools, the lava forms land. Maybe this is how the continents were born. As molten rock rose up through the ocean crust and burst out to form mountains, islands, continents. But where does all this lava come from? Three kilometers down below Hawaii, an immense chamber, big enough to feed all Hawaii's volcanoes. An immense chamber, big enough to feed all Hawaii's volcanoes. Magma surrounds us, reaches down through the crust, towards a mysterious layer of rock that separates the crust from the core, called the mantle. It's 2,900 kilometers thick and makes up 84% of our planet's mass. Yet nobody has ever visited the mantle, ever seen it. Until now. "16 kilometers beneath Hawaii, we've broken through the crust into the Earth's mantle. This isn't what we were expecting. It's not liquid, and it's not red hot. The rock is solid but movable, like fudge. And though the temperature down here is 1,000 degrees, it's the intense pressure, 25,000 times that on the surface, that keeps the rock from melting. There are no layers, few landmarks. If we want to find our way to the core, we'll need to see through the rock. Viewed from below, the crust becomes a world upside down, with peaks, troughs, plains. There's a parallel universe hidden inside our planet, an entire landscape that's a mirror image of the world above, inverted and distorted. As we travel west beneath Asia, the crust descends deeper into the mantle. 20 kilometers down, 30 kilometers. Above our heads, the Himalayas rise into the sky. Directly below, the crust pushes deep into the mantle. Everest is 8,848 meters high. This inverted mountain must plummet down at least 6 times that depth, to 70 kilometers beneath Everest's summit. Like an iceberg, the mountain's greater mass is hidden from view as it pushes down into the mantle.